Thank you so much for watching this online video tutorial. Like, comment, and share, as well as subscribe to our channel at Good Better Best Online Videos for more video content. Topic for today is we've just come out of learning balancing equations rather, and that was quite a good time in our lives, and we learnt it and we spent a lot of time on it as well. So no doubt, and I trust that everybody's knowledge of balancing equations is up to scratch. Okay, which is awesome. Okay, moving on to stoichiometry, which is the topic for today. Okay, now stoichiometry is arguably one of the most important fundamental sections in chemistry that does last all the way through up until grade 12. It does not disappear. It doesn't also change very much from the basics or the foundations that we're going to lay here in grade 10. In grade 11 and 12, it doesn't really change much. It's rather just things that are built on. Okay, so you'll find out as you journey through physical sciences, from now all the way through until matric, everything was a result of the foundation blocks laid here in grade 10, and everything else was just built on top. Okay, but most of the building happens in grade 11 and the decorating happens in grade 12. That's why for some of you, like with me, physics clicked only in grade 12. Okay, but let's find out exactly what does stoichiometry mean. Okay, now it's a part of chemistry, okay, that looks at a few things. Okay, well, it does look at the relative quantities of reactants. Okay, it looks at the relative quantities of reactants as well as the relative quantities of products, okay, in chemical reactions. Okay, so in chemical reactions, of course, you still need to know how to balance those reactions as well. Okay, because the balancing numbers are going to be used to determine some other factors, some other components that we're going to shimmy on through in just a couple of minutes. All right. Now, we do use stoichiometry to calculate quantities, such as the amount of a product. And we'd use that to calculate the amount of a product in the following: amount of product in terms of mass, moles, which is what we're definitely going to go through now, as well as volume. All right, that can be produced with given reactants, as well as percentage yield or percent yield, okay, which obviously gives the percentage of the given reactants that was made into a product. Okay, so lots of nice calculations that we can perform to get some nice little bits of statistics or stats, okay, and results that we can perform within this section. It's just once you nail it, you'll never lose it. Okay, if you miss it though, it can cost you, but that is the same with anything as well. Okay, so we're going to make sure that we nail this section, especially from now leading all the way through. Okay, now let's have a look at something that's called the mole concept, which is the word I mentioned earlier in the previous slide. Okay, the mole concept. Okay, so the mole is basically a unit of measurement, okay, which expresses, you need to take this down, okay, expresses the amount of chemical substance. So in other words, it's the amount of a substance, okay, or the amount of the reactant, or the amount. Okay, that's what is used by when you say how many moles. It's basically the amount of something that I have. Okay, it's the unit of, it's just called mole. Okay, now we use the mole as a unit of measurement because of the size of the atoms, ions, and molecules are so small. Okay, so the reason why we use moles is because we have atoms, or atom size, ion size, and molecules are small, So we use the mole as a unit of measurement. Okay, after this word is done. Cool. Now, we can define the mole as the amount of pure substance containing the same number of chemical units as there are atoms in 12 grams of carbon-12. Okay, so we use the carbon-12 atom here, which would be equal to about 6,02 times 10 to the power of 23 atoms. Okay, let me state that again. We can define the mole as the amount of pure substance containing the same number of chemical units as there are atoms in 12 grams of the carbon-12 atom, which is about 6,02 times 10 to the power of 23 atoms. Okay, so in other words, 1 mole of anything is equal to about 6,02 times 10 to the power of 23 of that object. Okay, atoms. Again. Okay. So, 1 mole of an element in grams contains about 6,02 times 10 to the power of 23 atoms. Another example, 1 mole of carbon equals 6,02 times 10 to the power of 23 carbon atoms, and 1 mole of bananas would be 6,02 times 10 to the power of 23 bananas. Okay, this number over here will be known, or is known under this section, as Avogadro's number. Okay, which is used as a symbol as capital N, capital A as a subscript. Okay, it's known as Avogadro's number. Okay, if I had to write out Avogadro's number in full, I'd probably run out of board. Okay, because there are quite a few zeros. Okay, and the unit of the mole is written as though MOL. So this first 3 here. So if you have to calculate the mole and get it into a answer, you just write it as MOL, okay, which is pronounced mol or mole. Okay, that's its SI units. Okay, like grams, you'd write just G for grams. So if you calculate the moles or anything, you don't write MOLE, you just write MOL. Even if it's like 16 moles, it's just 16 MOL. Okay, that's it. Okay, which is the basic unit of the amount of substances in chemistry. Okay. Okay, so some people might be asking the question, what is the mass of 1 mole? Okay, because we know how many atoms 1 mole of a substance is equal to. Okay, well, the mass of 1 mole okay, the mass of 1 mole of an element is equal to the relative atomic mass that can be found on the periodic table, right, of an element on the periodic table, okay? And it will be in grams, okay? So let's take an example here. 1 mole of carbon, okay, has a mass of 12 grams. Okay, and if you have a periodic table there on Access with you, I think I do here at the back here, this little notebook I got here, and there's at the key, usually on a periodic table there's a key or explaining where you find all the different things on the periodic table, what is what. The atomic mass of carbon is about 12, which is at the bottom there on the periodic table, so that means 1 mole of carbon has a mass of about 12 grams. Okay? And 1 mole of oxygen, okay, 1 mole of oxygen on the element has a mass of 16 grams. Okay, all on the periodic table. Okay, and 1 mole of helium has a mass of 4 grams, and 1 mole of sodium, for example, has a mass of 22 grams. and 1 mole of potassium has a mass of about 39, and so on and so forth. 1 mole of titanium has has a mass of 47 grams, or if you round it up on some periodic tables, might be 48 grams, because there's about 47,867. Okay, and so on and so forth. I'm sure you all catch my drift. Okay, where I'm going with this. Okay. However, the relative molecular mass of a molecule would be the combined relative atomic masses. Okay, so relative, and I'll obviously have an example to showcase this is that as well. Molecular mass is equal to the combined atomic masses. For example, let's take oxygen. Oxygen does not exist like this. Oxygen is O2, which is obviously going to mean 1 mole of oxygen element has 16, it has a mass of 16 grams. Okay, so obviously O2 is going to equal 16 times 2, which is going to give you 32. Now, the relative molecular mass is going to be 32 grams of oxygen, because this is an oxygen molecule. This is one oxygen atom. Okay, this is oxygen molecule. Okay, let's take H2O. We've got 2 hydrogens, and the relative atomic mass of hydrogen is 1 gram. So I've got 1 times 2 plus 16. All right, and that must give me, of course, 18 grams. Okay, but remember, back to the previous definition, a mass of 1 mole is equal to the relative atomic mass. So the relative atomic mass is actually measured in grams per mole to the -1. So when you are looking at your periodic table, the relative atomic mass, its unit of measurement is grams per mole. Okay? Cool. Basically, the relative atomic mass is also called another name called molar mass. Okay, which is basically the relative atomic mass. It's called the molar mass. Okay, it's the mass of any substance relative to the amount of the substance. Okay, so here we had O2, 2 oxygen atoms together in a molecule state. Okay, 16 times 2, 32 grams per mole. Okay, hope that makes sense to everybody. Right, there is another thing that's called relative formula mass. Okay, I'll just use an example to explain this. Now, relative formula mass, okay, let's say, for example, I have NaCl. Okay, now the molar mass of sodium, as I mentioned to you before, is about 22, in this periodic table, I've got about 22,999. So let's say sodium has a molar mass of 23 grams per mole, just rounding it up for now. And chlorine has a molecular mass of 35,453. So that is equal to about 35,5 grams per mole. Okay, and it's never rounded off to 36. I've never seen a periodic table that has rounded it off to 36, actually. Never. Okay, so now the relative formula mass would be as a result of the relative atomic masses of both of sodium and chlorine. Okay, so let's just make those lines a bit straighter. Okay, bring them together there, and you'll get an answer of roughly about 58,5 grams per mole. Okay, awesome, fantastic. Okay, that's the last one that I needed to explain. Okay, obviously we all understand the molar mass, though, is a substance the molar mass of a substance, rather, is the mass of any substance relative to the amount of that substance. So the molar mass is the mass of 1 mole of any substance, whether it's an atom, whether it is a molecule, or even a compound. Okay, and the reason why we get the unit grams per mole is because, let's take an example, helium, which we hardly ever use, but we know it makes people talk funny if you inhale it, like you talk a little squeaky and stuff like that. But it's 4 grams over 1 mole, which is basically the same as 4 grams per mole. Okay, so that's the unit for molar mass. All right, cool. We're looking at the mole formulae and calculations. Okay, of course there are 3 M's that we need to consider. One is M for moles, another M for mass, another M for molar mass. Okay, all part of the mole formulae. Of course, mole will be the subject of the formula. The formula is as follows. N is equal to small m over big M, where N is equal to number of moles. Small m is equal to the mass, all right, of a given substance. Okay, and that is given obviously in grams or measured in grams. Then we have the capital M. Okay, so often sometimes if I don't like to draw that, because it looks like, one, the McDonald's M, and number 2, it looks very similar to that M, and sometimes if it's a little bit off or not drawn correctly, then it can be confusing. So I like to draw my capital M the traditional way, and this would obviously be the molar mass of that substance or substances, and that will be, of course, in grams per mole. Cool, sweet. So that's the mole formula. N, the number of moles given by the mass of that substance divided by that substance molar mass. All right. Now, a little bit of an exam tip or test tip. You get marks for the formula. So you get a mark for the formula. You get a mark for the correct substitution, and your answer within the correct unit. Okay. So SI unit. Another thing you can add here to this list is your answer. Give it as X mole. Okay, like that. That's how you write it. Okay, that's SI unit, MOL, mole. Okay, sweet. That's the formula, as basic as that. Okay, very, very, very basic. Okay, let us take a little bit of an example using the formula. Okay, so let's come here quickly. I'll go back if I need to. Example 1. So let's say I have, let's give a big one. Okay, let's say I have about 15 grams of this little compound here, ammonium chloride, NH4Cl. Okay, and they're asking for the number of moles. Okay, so first things first, I've got my mass, right? So that should make me extremely happy. I got my mass. That's good, that's what I want. Now I need to go and calculate the molar mass. So what is the molar mass? First thing, molar mass of NH4Cl. Well, that's going to equal to the molar mass of nitrogen plus hydrogen and plus chlorine. Obviously, I've got 4 hydrogens. So I'm going to say, well, 14 plus 1 times 4. 1 is the molar mass of hydrogen, and 14 is the molar mass of nitrogen, plus 35,5, which is the molar mass of chlorine. Okay, 14 plus 1 times 4 is 4, plus 35,5 gives me molar mass of 53,5 grams per mole. Now I use my mole formula, therefore N is equal to little m over big M. So I've got 15 divided by 53,5, and therefore the number of moles that I would get, so let's just check it out quickly, of that substance would be roughly about 0.28 mole. This is just an example. All right. So I only got 0.28 moles of ammonium chloride. Okay, in 15 grams of ammonium chloride, I only got 0.28 moles. Okay, that's an example. Great, teens, thank you so much for joining me this session. Please stay tuned for the next video where we will be moving on to more practical calculations with the mole, with looking at percentage composition.